So your choice boards this week are about cover fractions, and one of your boxes talks about, or several of them actually, talk about comparing fractions, and there's a lot of ways to do it. One way is that you can just draw out a tape diagram for each of them, and then you can see which one is bigger. So if I was to compare, for instance, 3/7 and 6/9, I could say, well, I'll draw a tape diagram for each of these. So I'll draw 3/7 right here. The trick with this is that you have to make sure that your tape diagrams are the same length, and you have to have each of your boxes be exactly, a 1/7 of your whole or a 1/9 of your whole. So if I were to make my boxes like a really big one and then little ones the rest of the way, it wouldn't be the right size for each piece, and it would throw off my tape diagram. So this one works as long as you make your pieces very precise. So they're the same length boxes, and here's 3/7 and 6/9. So I'm going to put this into sevenths. 1, 2, 3, 4, 5, 6, 7. Those look pretty close. This one might be a little bit bigger, maybe than like this one, but that's pretty good. And then ninths. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now I'm going to shade in 3 on the 7th side. 1, 2, 3, and I'll shade 6 on the 9th one. 1, 2, 3, 4, 5, 6. Now this one seems pretty obvious that the 6/9 are farther out than the 3/7. You can see there's this line right here where they're the same, and then I've got 2 more on this side. So I could put on my inequality that 6/9 is greater than 3/7. We'll do that once more with the different fraction. Let's see, how about 4/10 and let's see, how about 2/6? Okay, so I'll draw my tape diagrams out again. Try to make them the same length. And this will be my 6th, 2/6, and 4/10. Let's see, so 6. So here's halfway. 1, 2, 3, 4, 5, 6. And 10ths, here's halfway. So 1, 2, 3, 4, 5. And 1, 2, oh, that's not quite even. 1, 2, 3, 4, 5. Okay, so I'm going to shade in 2/6 over here. 1, 2, and then 4/10 over here. 1, 2, 3, 4. Okay, so these are a lot closer together. It looks like 4/10 is probably bigger than 2/6. However, this one is so close that if I had drawn my boxes maybe a little bit bigger than another box, or a little smaller on one part, it's very possible that they could be equal, or 2/6 might really be bigger, even though it looks like 4/10 right now. So there's a couple of other ways to compare as well. One way is that I can make the numerators the same. And another way is that I can make the denominators the same. Remember, in fraction, the top of a fraction is called the numerator. And that's basically the number of parts that you have shaded in, or the number of parts that you have. Like if I had if I made a batch of cookies and I ate 3, I would have eaten 3 out of how many total there were. And the denominator on the bottom, denominator, is how many total I have. So in this one, 4 will be the number I have shaded, and 10 will be the number total that I have. So I can say I ate 4 out of 10 cookies on this one, for example. Okay, so if I wanted to find the common, let's do common denominators first. I have to look at, or actually let's do numerators. I like numerators. No, let's do denominators. Okay, so I've got 2/6 and 4/10. Gotta make it in my mind. Okay, and I want to have the same number down here, 6 and 10. And I'm thinking, okay, what's a common number that both 6 and 10 can go into? Well, if I start with 6, I think, okay, let's see here, 6, 12, 18, 24, 30, 36, 42, 48, 50, 54, 60, 66, and we're gonna have space. Okay, I'll stop there. Then with 10, we would have 10, 20, 30, 40, 50, 60, 70, I'll just go up a couple more, 80. All right, so now I've got these two sets of multiples. I'm trying to find one where they have the same number. And I thought I saw one. Let's see here. 30 is the smallest number that they both share. They also, looks like they also share 60. Right there. So I could have either said, I'm going to turn these into 60s, or I could turn it into 30. Either one would work. Sometimes it's easiest if I just say, well, just multiply them by the opposite. Like I'll multiply 10 by 6 and 6 by 10, and then I'll have the same numerator. Or I could just go with the smallest number that they both share with 30. I'll do 30 right now. So 10 times 3 would be 30. So I'm going to multiply that by 3 over 3, because 3 over 3 is really just 1. I'm not really changing the fraction at all. And that will give me 30, and 4 times 3 is 12. And I'll multiply this one by 5, because 6 times 5 is 30. And then 2 times 5 is 5 fifths is really just 1. 2 times 5 is 10. So we've got 10 30ths and 12 30ths. So now that my denominators are the same, I have the same number of parts, I can see that really it is true that 4/10 is bigger just by a little bit than 2/6. And what we did right here was really, we just split this up into 3 parts going the other way. Now I have 30 right here. 3 times 10 is 30. And I broke this up into fifths. 1, 2, 3, 4, 5. 5 by 6 is 30. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's one way if I wanted to find common denominators, and then the one with the biggest numerator, the biggest number on top, the most shaded, would be the biggest number. Another way to do it, we'll go over here, is to find common numerators. And we have 2/6, I'll do it right here, and 4/10. All right. So now I'm trying to find a number for 2 and 4. So I'm going to find those multiples. Are those showing up okay? Let's see. Make this over so much darker. Okay. So let's see. I'll make multiples of 2 here. 2, 4, 6, 8. I'll stop there. And then 4, 8, 12. If you notice, once again, we've got 4 and 4. We also have 8 and 8, but I'm going to go with the smallest one. So I've already got 4/10 here. I can leave that one. I'm going to multiply 2/6 times 2 over 2 to get common numerators. So 2 times 2 is 4. Now I've got 4s. And then 6 times 2 is 12. So now I have 4/10 versus 4/12. So this is where it gets a little confusing, because when the 4s are the same, when the numerators are the same, the bigger number actually has the smaller denominator. And if you think about it, if you have a whole, right? And you have, maybe it's a pie, and you have to share it with somebody or somebody's, when would you get most of, or more, a bigger piece? If I had to share it with one other person, Or if I had to share it with 5 other people, or, you know, 4 other people, and I had that. You'd be like, well, I'd want that part of it, right? That gives me more of the pie. I have to share it with less people. When I shared it with 4 people, my piece is smaller. So basically what the denominator is saying is, how many people are you sharing it with? What's the size of the piece? And with a smaller denominator, you have bigger pieces. So 4 are the same. These pieces will be bigger. So those are doing it with tape diagrams, with numerators, and with common denominators. We'll do another problem here in a different video in just a second.